look for an abstract, this is basically your one paragraph summary. This tells you everything which the author wants you to know about the paper. So it tells you some background, it tells you what they're trying to do, it tells you the results of what they did, and tells you the conclusion about what they did in one paragraph. So it's basically one sentence approximately for each section in your lab report, in the research article. Then of course there's the introduction. This is introducing, topic, hypothesis, experiments. It's basically giving the reader kind of the full scope of what's happening and why they're doing it. Then of course they have the materials and methods section, or sometimes just called the methods section. It has materials in it, but it's just been abbreviated to methods in a lot of papers. And it's just telling you the how-to. How do they do it? And so there'll be a lot of technical jargon there, talking about equipment, talking about techniques and whatnot. This is where a lot of students get frustrated in this section right here, and this section a little bit too, because they'll run into terms they have no idea what they mean. And nowadays, on the internet, most things have been described on the internet. You can find most of it on Wiki actually, what different techniques mean, what different terms mean. Their physiology is an old enough topic and a well enough studied topic that there is plenty of internet material out there for you to learn all this stuff. And if not, you can really just look at the appendix of your textbook. A lot of these techniques are very classic techniques that if you just Google it, you can find it out. It's pretty, we don't do too many fancy things in physiology that involve cutting edge technology, not too often. So a lot of these techniques are classic and are well described. And so don't ever be afraid of looking up stuff. That's kind of how you learn a field. That's kind of how you learn science, looking up stuff over and over again. Then of course the results section is what they got. And the idea is they're just describing simply the data they got. In the materials and methods section, they're telling you how they got the data, and the results section is, well, here it is. There's no spin to it. There's no analysis to it. It's like, here it is. These are the numbers, and these are the trends, and this is the stats behind it. That's what the results section is. Most often they'll have figures. Figures that 95% of the time, figures go into the results section. In your lab report, your figures should only go in your results section. And these are just to help the reader, understand a lot of data, right? It's not useful to show people a bunch of numbers. We're not computers. We can't. It's hard for us to decipher a list of numbers. And so these are just to graphically represent that, and that's why we have figures. And lastly is discussion. It's basically what do they make of their data. The idea is okay, we got this. What does that mean? What does that mean to the question we're answering? What does that mean to the topic at hand? And so I've posted an example paper for you to look at. It's a pretty cool paper to read because it's pretty relevant to pretty much everyone here. There's not many people who don't look at a screen of some sort in the evening before they go to sleep, whether it's your phone, tablet, or computer. It's pretty prevalent. And so this paper is a paper from the journal PNAS, the Proceedings of the National Academy of Science. It's a very popular, very well-known journal. And so oftentimes you'll see a paper like this, and the title and authors will be formatted as such. And so this paper is on Canvas, in PDF. You can go check it out. It is a decently good guide on how a research article reads and looks like. So if you need an example of what your lab report should kind of look like, you can look at that. For my lab class, I also posted a sample lab report on my lab section, so you can go check that out too. But yeah, so where you should start out with a paper. You have a paper in your hand or on your computer. Where do you start out with? You want to start out by vetting your paper. You don't want to read a paper that's bullshit, basically. And so a couple things you want to do is you have to understand what's being presented. So all of this stuff, this is the title. Dandy. The title should tell you their results, the major finding they have. It shouldn't be vague and cryptic and be like, it shouldn't be like the effects of iPads on your sleep. Like that's an article, that's a title for a blog post, not an. And the reason blog posts make that title so you can get like, oh, what is the effect? Let me read it. That's not the point of research articles. Research articles don't need to entice you to read it. You're there to read their paper. They don't have to attract you like a blog post has to or a newspaper article has to. You're there because you want the information. So, and like just like your lab report, you should be upfront about what you got. If they're already there, they're already going to be reading it. Tell your reader what you found. And so that's what the title is. It's something that tells you what it's about. And the whole point here is it negatively affects sleep, circadian rhythm timing, and next morning alertness. That's the result. And here is the string of authors. Basically what you need to know is this first author is this person, Anne-Marie is the person who actually ran the experiment, did the data analysis. She is the person that did most of the work and pioneered most of this work. And then chances are she was mentored or supervised by this last author, by Charles, I can't pronounce that last name. Thank you. Anyway, so that's kind of generally how it's broken down. The first author is the one who primarily did the work, or is taking main credit for doing all the work. And the last person is like what we call the principal investigator, the supervisor, the person who supervises the project in a grander scheme. And then everyone in between are people who helped out. And they could be a varying contribution. They could help out a lot, and they could help out a little bit. It's up to the people writing the paper who gets to go in the middle section or who doesn't go in the middle section. If you're an undergrad and you ever get partake in research that gets published, chances are you'll be one of these middle authors. But what's more important to see who wrote it is actually to see where this paper came from. This paper came from the Brigham and Women's Hospital in Boston. And this is a pretty well-established place of research. And the point here is to find out what are the institutions that are funding or supporting this research, because not all institutions are unbiased. This one is a well-known institution. They're known to being unbiased and giving you the facts straight up. This is the analogous of, I don't know, Washington Post or New York Times or The Hill or something like that. But there are other places that put out papers that are simply not good. Sometimes you'll see papers from an organization called the Discovery Institute, and that name sounds really official, like, oh, it's an institute. That sounds fancy, that sounds scientific-y and whatnot. But it really isn't. They talk about things like intelligent design. They talk about making things great again. That's a throwback to something else in the current politics. This is actually a very biased institution, and if you read their papers and you scrutinize them, they're not unbiased. They're giving you a slant. They're trying to throw out data that you're not sure is real data out there. And so whenever you find a paper and you find an institute that you're not sure, so if it's some institute that's not a university or something like that, go Google it. This is their front page of Discovery Institute. You can tell in 3 seconds that this is probably a biased institute. So, check it out. Another way to vet your paper is to simply Google your paper and specifically find all the papers that cite this paper. And so if you do that, just peruse the titles. See what they're saying. Are they saying things that support the title of your paper? Or are they papers that are refuting what your paper is going to be talking about? And that gives you an idea about how the scientific community views that paper you're going to read. Sometimes they're going to cite and be like, yes, this is a source of good information. I'm going to build off it to do something else. Sometimes they're writing a paper to say, this is horseshit. This paper's no good. There's all these flaws with it, and here are all the flaws. And you get to see that when you kind of hit this cited by button, and you get to see all the different titles. Now, why go through all this trouble to vet a paper? Well, first of all, reading scientific papers is time consuming. It's not a one and done situation. Don't read it once and be like, ah, that was a nice read, and internalize all the information. You're gonna have to read it multiple times. You're gonna read it 2, 3, 6 times. I read paper like 3 times, 4 times to really understand it, and I've been reading papers for years. Scientific papers are not meant to be a one and done thing. They're packed full of information, and they need to be digested over many hours. And so before you dive into a paper, you want to make sure it's a paper worthy of your time. Also, you don't want to read a paper and then use it having later figured out that it was a bad paper. You don't want to basically make yourself look stupid by giving out bad information, or even worse, giving bad information to people who don't know it's bad information. That's basically propagating bad science. That's another reason why you want to vet the paper before you read it. So after you've done all that, then you can finally read your paper. And step 1 is to read the introduction. And I mean read the introduction and ignore the abstract. So this is the paper I posted up, and that first paragraph there is your abstract. Ignore it. I know it doesn't sound right, but just ignore it. The abstract doesn't get vetted nearly as much. Author tends to put their own spin on the abstract to make you think a certain way. Don't do that. Make your own conclusions from their paper. Don't have them inform your conclusion, at least in the beginning. So don't read the abstract. Just jump straight into the introduction, which starts here. And let's just read through it. Now, this is a very short introduction. Not all papers have a short introduction. Your lab report should not have a short introduction. And this is a short introduction because this is in a somewhat of a short journal format. Some journals have large papers, some journals have short papers, and so they'll require people to have very